video. Today we're going to go over Leetcode problem number 171, Excel sheet column number. So this problem is pretty simple. We're just given a column title like you would see from Excel, and we're going to return the corresponding column number. So if you have A, you return 1, and if you have B, you return 2, all the way down to Z, where you return 26. There are 26 letters in the alphabet, so that should make sense. And the pattern continues by just starting over at A again, and we have that's 27, and AB is 28, so on and so forth. So the problem is pretty easy to understand, but we have to figure out what kind of algorithm could possibly help us convert from a string of letters to the actual numerical value. So let's draw this out and see how it works. We know that if we're just given a single letter, it's pretty easy, right? Because A is 1, and going down through the alphabet, Z is 26. We're literally just counting the letters in the alphabet here. And that's fine, because it makes our solution a bit easier. All we have to do is just store what numerical value each symbol corresponds to. But the problem is a little harder because we have strings like AA. And even harder, we have AAA, and 4 A's, 5 A's, so on and so forth. So remember, from the problem description, AA is 27. And since we could theoretically have an infinite amount of these strings, we can't just store them all in a dictionary and use that to perform the conversion between symbols and numbers. So we're going to have to look more deeply at the pattern here. Notice that this entire collection of strings that you can generate repeats in cycles of 26. So this should immediately bring to mind what you may call a base 26 number system. Let me explain what I mean by that. So if you think back to our normal base 10 number system, for example, if we're looking at the number 15, we know that the number of symbols we can use, or digits, is just 0 to 9. So there are 10 digits that we can call upon to form our everyday numbers, right? Here we chose digits 1 and 5. And how do we actually determine the value that this collection of digits represents? Well, what we do is look at the places of each digit. This is the ones place, right? In other words, 10 to the 0th power. And this is the tens place. In other words, 10 to the 1st power. And we can calculate the total value by just multiplying 5 by 1, which is 10 to the 0th power, and multiplying 1 by 10, which is 10 to the 1st power. And you notice that this simple process gets us 15. So we have a similar scenario here, where instead of having 10 as the base, we have 26 as the base, right? We don't just have 10 digits to choose from, or symbols, you can call it symbols. We have 26 symbols to choose from, A through Z. So we're going to change this 10 to a 26. 26 to the 0th power, 26 to the 1st power. And we're going to do this same additive process, the same addition, to calculate the true numerical value of this string of letters. So let's do it for AA. We know that this should be 26 to the 0th power, right? And we know that A represents the value 1. So we have 1 times 1 plus, so this place should be 26 to the 1st power, right? And we know again that A represents 1. So we're going to do 1 multiplied by 26. Again, we're just doing the same thing as we would do for a base 10 number system, but in base 26. And we get 27, which is correct. And you didn't have to do this starting from the right-hand side. You could start all the way to the left, too. So let's see how this actually works if you're going to code it out. First, we need a result variable. And then we need to figure out what power we're starting at. So we're going to call this start power. It's going to be length of the characters minus 1. And then we're going to go through each symbol, digit, or letter, whatever you want to call it, in the string, right? And we're going to start on the left-hand side. So first, we need to get the value of the letter we're looking at. So if we're looking at A, we have to somehow know that that actually represents the numerical value 1. And in Python, there's a very easy way to do this. You just do ordinal value of the character minus ordinal value of A. So this is a very useful trick for you to keep in mind. If the ordinal value of A is, for example, 56, and the ordinal value of the character you're looking at is, let's say, A, then they would have the same ordinal value, and this would resolve to 0. But A is equal to 1, not 0, so we're going to add 1 to this arithmetic. And this line of code right here is basically what allows us to easily convert between these single letters and their actual numerical values. So given that we have this, we're going to multiply this by 26 raised to the starting power. And since we start all the way on the left-hand side and we're going to the right, we're going to have to decrease the power as we move further to the right. So start power minus equals 1. And we have to remember to add the result of this arithmetic to the result. And then we're just going to return the result. Okay, now let's see if this works. Great. Okay, so hopefully this was helpful. The time complexity here is basically linear. We're just going through all the characters of the string and doing some arithmetic. All right, thank you for watching, and I'll see you later.